Alright, we're on our last note set for Unit 3, and we are going to be graphing linear inequalities in two variables. Those two variables being, yes, of course, x and y. You are going to need a ruler for this one, so if you don't have one, you should grab one. And if you don't have one, you could make one. Just fold a piece of paper a couple of times and it'll have a nice straight edge. So a linear inequality is similar to a linear equation, but the equal sign is replaced with the inequality symbol. So you remember graphing y equals 1/2 x plus 3. This is very similar to that, except it's going to contain a greater than, less than, greater than or equal to, less than or equal to symbol instead of an equal sign. A solution of a linear inequality is any ordered pair, xy, that makes the inequality true. We use a graph to show the solutions because there's an infinite amount. So the solutions will go on forever and ever. Rather than listing them for the rest of our lives, we just make a graph. The graph of a linear inequality in two variables shows all the solutions in a coordinate plane. And the boundary line that divides the coordinate plane into two, it's called the two half planes is what it divides it into. I know that's part of your vocabulary, so maybe you want to look that up, hit pause, go and fill that in. Or just keep watching, whatever works for you. Alright, here are the steps. How do we solve a linear inequality? Well, step 1, you solve the equation for y if it's not already in the form of y equals mx plus b, just like you did before. Except instead of an equal sign, you're going to have an inequality sign. So just solve for y. Get y by itself so it's in the form of y equals mx plus b. Remember to flip the sign if you end up multiplying or dividing by a negative to solve your inequality. Then you're going to go ahead and graph the line. So when you graph your line, this is just plot the y-intercept, use the slope as rise over run to figure out the other points on the line, just like you did before. But if your y is followed by a greater than or a less than symbol, the line that you use should be dashed because it means that your solution points are either less than or equal to the points on that line. They're not less than or greater than the points in that line, not equal to them. So you'd need a dash line. If you see that you have a less than or equal to or greater than equal to after the y, then you can make a solid line because it means that your solution points can be equal to those. If y ends up being greater than or equal to, you're going to end up shading all the values above the line because those are all the y-axis values that would be greater. If you get y is less than, you're going to end up shading below the line. And all you have to do to test points is just plug in for x and y into the inequality and see if the result is true. So you can check to make sure that you've shaded in the right direction. Now again, let's make all these words real because sometimes just the step-by-step isn't quite enough as seeing a real live example. So here we go. Take a look at the first example here. I'll zoom out just a little. Well, I'll zoom in and then I'll zoom out when we do our graph. So we have y is less than or equal to 2/3 x plus 4. I like that because, hey, it's already solved for y. So I'm going to graph this just like I did before. I'm going to plot the y-intercept on my graph. So this plus 4 means that the y-intercept is 0, 4, 1, 2, 3, 4. And then 2/3 x, my slope is already in the form of a fraction. 2/3 means up 2, right 3. Up 2, right 3. Now, notice that this is less than or equal to. So that means my solution can be points on this line. So I'm going to get my ruler and I'm going to make a nice solid line all the way across your graph. Okay, last part. If we're saying that y is less than or equal to that, that means that it can be any point on this line will make it true, and all the values that are less than that. So here's my y-axis. If this is my starting point, the values above would be the higher value y, so greater than, and the values below would be the less than. So if y is less than, that means I'm going to shade in all of these values underneath the line. Do you see why you want your graph to extend all the way across? That's what your graph looks like. We get to color in math. How great is that? Okay, so now I said to test point, substitute x and y into the inequality and see if the result is true. What this means is that any ordered pair that I find underneath here or directly on the line, all of these are all solution points. And if you plug in the x and y ordered pair into this, it'll make the statement true. A really easy solution point to plug in is 0, 0. So if you see that 0, 0 is on there, I would use that. And this is what I mean by checking solution points. If I'm going to choose 0, 0, because that's a portion of this graph, then I'm going to plug 0 in for x and 0 in for y. So 0 should be less than 2/3 times 0 plus 4. Is 0 less than or equal to 2/3 times 0 is 0, and 0 plus 4 is 4? Is 0 less than or equal to 4? It sure is. That means we shaded it in the right direction. So if you want to know, did I shade this in the correct spot? Just plug in a point. If you were to plug in any ordered pair up here, it wouldn't work. You'd end up getting a false statement, like maybe something like 6 is less than or equal to 4, and it's not. So that's how you can check it. All right, take a look at this next one. I have 4x minus 6y equals 12. Okay, we're going to solve this one. We need to solve it for y because it's in standard form right now, and I want it solved for y. So draw my line. I need this x to move it. So I'm going to subtract 4x or add negative 4x. I'm left with negative 6y and 12 minus 4x. Those aren't like terms. I can't combine them. Now to get rid of this negative 6, I need to divide this side by it, and that means I need to divide each one of those terms by it. So those equal 1, and 1y is y. 12 divided by negative 6 is negative 2, and notice it's a negative 4 over a negative 6. That means positive result, and 4 6 simplifies to 2/3. So I'd have negative 2 plus 2/3 x. Now do you see how we divided by that negative 6? Originally the symbol was pointing that way. We need to flip it around. So it should be y is greater than negative 2 plus 2/3 x. At this point we're solved for y. We're going to graph it. My y-intercept is negative 2. My slope is 2/3. That means up 2, right 3, up 2, right 3. Now I have to decide, is it a solid line or a dashed line? If y is greater than that, it means it can't be an actual point on that line. So when you take your ruler and set it up, instead of drawing a solid line across, you want to make a dashed line that looks like that. It does make a difference, because if you make the solid line, you're saying that any of these will be solution points, and they're not. So it has to be dashed. Now, we've decided on the line. Now we have to decide shade above or below. Y is greater than, right? So here's my y-axis. These are the higher values. These are the lower y values. So if y is greater than, it means I'm going to shade above. So let's shade above. La, la, la. Color, color, color. Wait till we get to systems of these. Oh, it's so much fun. You're going to love it. Okay, so this means that any ordered pair in here will make this statement true. And again, we see that 0, 0 is one of them, right? So if I did plug in 0, 0, 0, that would mean we could just use our original equation. Why not? 4 times 0 minus 6 times 0 should be less than 12. Well, 0 minus 0 is 0, right? Is 0 less than 12? Uh-huh. So that means I shaded the correct way. Yay! Go us. We rock. Okay, here's another one. It's not solved for y. Let's solve it for y. I'm going to subtract 5x. I'm left with 3y here and 18 minus 5x here. Now I need to divide by 3. So y, and I didn't have to change any signs or anything, so I didn't divide by a negative. 18 divided by 3 is 6. And then minus, I'm going to leave this as 5/3 x because I have to graph it anyway, and it needs to be a fraction to graph it. So we're solved for y. Let's go ahead and plot it. 6 is my y-intercept, so 0, 1, 2, 3, 4, 5, and 6. This is minus 5/3. That means that I can go down 5, 1, 2, 3, 4, 5, and right 3. I could also go up 5, left 3, but there's not enough room, so I'm going to go down 5, 1, 2, 3, 4, 5, and write 3 one more time. All right, now I have to decide, dashed or solid. Well, it's less than or equal to, so when you see that line underneath, that means a solid line on your graph. So let's draw our solid line. And now I have to decide, okay, here's my starting point. Am I going to shade up here, or am I going to shade down here? It says here that y is less than or equal to -6. So here's my starting point here on the y-axis. The values underneath it are lower, so that means I'm going to shade under. So go right ahead and do that. All right. Voila. So again, I can check any ordered pair in here and see if it makes it true. If I made this as one of my solution points to check 0, 0, 5 times 0 plus 3 times 0 is 0. Is 0 less than is 0 less than 18? Yes. So I know that I shaded the right way. Okay? Ooh, this one's nice. Y is less than -5. So it's already solved for y, right? I don't see a coefficient of x. That means my slope is 0. A 0 slope means a horizontal line. So on my y-axis, 1, 2, 3, 4, 5 down to -5. And now I have to decide solid line or dashed line. Y is less than -5. It means it can't be -5. That means I need a nice little dashed line. So set up your ruler. We're going to make dashes. Okay. So it says that y is less than. Here's my starting point. All the points above are going to be greater than. All the points below will be less than. So with less than, I'm going to shade under it. And any point that I would pick here, so x is going to be 0 here. So let's say I picked 0, -6. Is -6 less than -5? Yep. So is -7, so is -8, so is -9. So any point that you pick in here will make that statement true. All right, next page. Keep going. You can do it. We're almost there. So I showed you one that was solved for y. Now let's show you one that's solved just for an x. You need to remember when I have an x, that means I'm not going to have a horizontal line. That means I'm going to have a vertical line. It's an undefined slope. So x is greater than or equal to 7. That means on my x-axis, I'm going to go over to 7. Since it's greater than or equal to, that means I can make a nice solid line. Okay, so think about this. If the x is greater than 7, that means my x value should be greater. So I'm going to be looking at my x-axis. If this is my starting point, those values will be lower because I'm heading in the negative direction, and those are the values that will be higher. So we should be shading to the right. Okay, so that's how you do the graph. Basically, we're really piggybacking off of our linear equations unit, but just applying the inequality symbols to it. Next, I want you to be able to tell whether an ordered pair is a solution without actually graphing it. And all we have to do with that is, yes, plug it in, plug it in. So if we have 2x plus y is less than -3, and I want to know, hey, is -9 a solution point on that? All you have to do is plug -1 in for x and 9 in for y and see if the statement is true. So 2 times x, which is -1, plus y, which is 9, should be less than -3. 2 times -1 is -2. -2 plus 9 is 7. And is 7 less than -3? No. That means that -1, 9 is not a solution to that graph. Or it's not a solution point on that graph. All right, let's try another one. I have x minus 3y is greater than or equal to 8, and I want to know, is 2 -2 a solution to that? So all we have to do is plug it in. We're saying that x is 2, so 2 minus 3 times y is -2 should be greater than 8. And 2 minus, actually I'm going to do that. -3 times 2 is 6. 2 plus 6 is 8. Is 8 greater than or equal to 8? I know 8's not greater than 8, but 8 is equal to 8, and only one of those things has to be true. So this would be a yes. 2, negative 2 is a solution to that. All right, we're almost there, but I couldn't let you go without having math story time. It's been a while. We didn't have story time last time. All right, so it's about food, because everybody likes food, right? Okay, so you can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound. Apples cost $1 per pound. Write and graph an inequality for the amounts of grapes and apples you can buy. Identify and interpret the two solutions to the inequality. Okay, so where on earth do we begin? Well, we're supposed to graph this thing, right? And if we're going to graph this, I think an equation would be very helpful. So, let's see here. It says you can spend at most $10. That seems pretty important. Grapes are $2.50 a pound and apples are $1 per pound. I think that's all the information I need. Now I'm hoping that you're noticing that I just gave you two rates. I gave you $2.50 a pound and $1 per pound. When you're given two rates, that should flash the signal to you of, oop, I need a standard form. So we have our $2.50 a pound of grapes, plus we have $1 per pound, and that would be 1y, so I'm just going to say y. And I know that I can spend at most $10. That's what it says. So at most $10 means I can spend $10, but 10 is the most I can spend. So that means I can spend 10 or less. So when I add up my grapes and my apples, I should get an amount that's less than or equal to 10, because 10 is the most I can spend. Hopefully that makes sense. All right, so now we're going to graph this. When we go to graph this, it's easier if it's solved for y. So let's solve it for y. That means I need this 2.5x to move it. Because I like to move it. Sorry, I couldn't help myself. Sometimes it just happens. All right, so when you move this, you end up having y is less than or equal to 10 minus 2.5x. Now in graphing this one, my slope right now isn't in the form of a fraction, and I would like it to be. There's a couple different ways that you can do this. You can say, okay, well, negative 2.5, that means I have 2.5. And if you have 2.5, 2 times 2 is 4, plus 1 is 5 halves. So y is less than or equal to 10 plus negative 5 halves x. That works. So this is what I'm going to graph. I need to make sure that I have enough room on here for my number skills. So let's see, y is less than or equal to 10 plus negative 5 halves x. My starting point here would be 10, and do I have enough lines to count by 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, yes I do. Alright, so there's my starting point. My slope is negative 5 over 2. So that means from here I want to go down 5. 1, 2, 3, 4, 5, and write 2. And down 5, 1, 2, 3, 4, 5, and write 2. It says that y is less than or equal to. So that means I need a solid line. And if y is less than, that means I want to shade all the values below. I'm not worried about going into the other quadrants except for 1, because I'm not really going to have negative values here. Those don't really apply, do they, to this situation? Okay, the last thing I asked was identify and interpret the two solutions to the inequality. Well, here's one. It's my x-intercept, right? My x-intercept is 1, 2, 3, 4, 0. And my y-intercept is 0, 10. What those solution points mean is that y represents the pounds of apples, right? So that means I can buy 10 pounds of apples with 0 grapes, or I can buy 4 pounds of grapes with 0 apples. You are done with Unit 3. Congratulations.